Good morning, students. Today we are going to read very important topic in chemistry, that is giant covalent structure. So concentrate yourself. This is very important topic. We are going to start. Carbon atoms can bond to millions of other carbon atoms in both diamond and graphite. First topic in giant covalent structure, we are going to read carbon in the form of the diamond. Diamond has always been valued for their sparkle and fire. It is used in industry for cutting, grinding, and drilling. Diamond is the hardest substance on earth. Diamond is made from only carbon atoms. Look at the figure. Here is the structure of the diamond. This is giant covalent structure of the diamond. Strong covalent bonds between all the carbon atoms. And this is the structure which you have to learn how to draw it, because in paper the structure of the diamond or graphite is often come to draw. So here is the structure. Each atom forms 4 strong covalent bonds with its neighbors. The atoms are arranged in a giant covalent structure. Diamond has a giant molecular structure. All the carbon atoms are bonded together by strong covalent bonds in a 3-dimensional lattice, which extends to the edges of the crystal. Each single crystal of diamond is one giant molecule. Each carbon atom is bonded to 4 other carbon atoms in a tetrahedral arrangement. Each and every point is very important. Each carbon atom uses all of its 4 valence electrons to form 4 covalent bonds to 4 other carbon atoms. Now we are going to read the properties of the diamond. First property is hardness. Diamond is the hardest substance known. This is again very important question as far as MCQs are concerned. Second point about hardness is the carbon atoms are not able to slide over each other because all the atoms are bonded together by very strong covalent bonds in a giant molecular structure. Next property is volatility. Diamond has a very high melting and boiling points. A lot of energy is needed to break the billions of the strong covalent bonds between carbon atoms. Next property of the diamond is electrical conductivity. Diamond does not conduct electricity. Each carbon atom uses all of its 4 valence electrons for bonding. Hence, it does not have free electrons to conduct the electricity. This is the reason. That's why diamond is not able to conduct electricity. Very important points. Another compound with a giant covalent structure is sand. Its chemical name is silicon dioxide. Formula is Si2O. It melts at over 1500 degrees C. Substances with giant covalent structures are not soluble in water. Very important point. Their particles have no charge, so water molecules are not attracted to them. This is the reason. That's why giant molecular structures are not soluble in water. They don't conduct electricity in any state. There are no free ions or electrons to carry the charge. Graphite is an exception. Remember it. Next point, very important, which we are going to discuss in giant molecular structure is graphite. Carbon in the form of the graphite. Diamond and graphite are allotropes of carbon. Allotropes are different forms of the same element in the same state. The carbon atoms in graphite are also held together in a giant covalent structure. However, some of the properties are very different from typical giant covalent substances such as diamond or sand. If you touch a lump of the graphite, it feels smooth and slippery. Your pencil contains graphite. As you move it across your paper, it flakes off, leaving a trail of the carbon atoms. And look at the diagram below. This is the structure of the graphite. The giant covalent structure of graphite. Strong covalent bonds between the carbon atoms in each layer. But weak forces hold the layers together. How many carbon atoms are joined to each other by strong covalent bonds? Here is a question. And why is this strange? So read it. The fourth electron from each carbon atom is found in the gap between the layers. These electrons hold the layers together by a weak force. The layers can slide over each other easily. Does this explain its use in the pencil? Yes, this is the reason. The fourth electron from each carbon atom is found in the gap between the layers. These electrons hold the layers together by a weak force. The layers can slide over each other easily. This is the reason graphite is used in pencils. Do you know the only non-metal element that conduct electricity well? So this is the element graphite, which is non-metal and can conduct electricity. Electrons hold in the layers together in graphite. However, they are only held loosely to the carbon atoms. They can drift along between the layers in graphite, making it a conductor. So this is the reason. Graphite does not melt when you heat it. At over 3000 degrees C, it turns straight into a gas. We say it sublimes. Graphite also has a giant molecular structure. Graphite has a layered structure consisting of millions of the layers of the carbon atoms. In each layer, all the carbon atoms are bonded together by strong covalent bonds in a two-dimensional lattice, which extends to the edges of the crystal. Each layer becomes one giant molecule. Each carbon atom is bonded to three other carbon atoms in a hexagonal arrangement to form rings of the regular hexagons. So, very important point. Each carbon atom is bonded to three other carbon atoms. Each carbon atom uses only 3 valence electrons to form 3 covalent bonds to 3 other carbon atoms. The different layers of the carbon atoms are held together by weak van der Waals forces of the attraction. Properties of the graphite. The first property is hardness. Graphite is a very soft substance. The weak van der Waals forces of the attraction between the layers are easily overcome, and this enables the layers to slide over each other. Next property of the graphite, volatility. Graphite also has very high melting and boiling points. A lot of energy is required to break the billions of the strong covalent bonds between the carbon atoms. Next property of the graphite which is going to be discussed is electrical conductivity. Graphite conducts electricity. Each carbon atom uses only 3 out of its 4 valence electrons for bonding. Hence, it has one free electron to conduct electricity parallel to the layers. Table shows the different properties of the diamond and graphite. This is very important question which frequently come in the paper. So concentrate yourself. We are going to read the differences between diamond and graphite. The first property which is going to be discussed in both diamond and graphite is appearance. Diamond is transparent, colorless crystal, whereas graphite is black, opaque, shiny solid. Density in gram per centimeter cube of diamond is 3.5, whereas of graphite is 2.2. Hardness of the diamond is very hard and hardness of the graphite very soft. Volatility of the diamond is high melting and boiling point, and same in graphite, high melting and boiling point. Electrical conductivity of the diamond does not conduct electricity, whereas graphite conducts electricity. Electrons can move along between the layers of the graphite. So this is the diagram which is showing how electricity conducts in graphite. Here are present electrons, which is the 4th valence electron, which is not used to make the bonds, and these electrons can conduct electricity between the layers. Next topic in the giant molecular structure is silicon. Silicon has a giant molecular structure similar to diamond. All these silicon atoms are bonded together by strong covalent bonds in a 3-dimensional lattice which extends to the edges of the crystal. Each silicon atom uses its 4 valence electrons to form 4 covalent bonds with 4 other silicon atoms. Each silicon atom is bonded to 4 other silicon atoms in a tetrahedral arrangement. Figure shows the structure of the silicon. Here is the structure, and you have to learn it how to draw, because in paper this is normally come to draw the structure of the silicon. Properties of the silicon are similar to those of the diamond. Silicon is a hard substance, though not as hard as diamond. Silicon also has very high melting and boiling points. Pure silicon does not conduct electricity but becomes a semiconductor when impregnated with impurities. Next topic is silica, that is also called silicon oxide. Silicon oxide has a giant molecular structure similar to diamond. Each silicon atom is bonded to 4 other oxygen atoms in a tetrahedral arrangement. Each silicon atom forms 4 covalent bonds with 4 oxygen atoms. Figure shows the structure of the silicon oxide. Here is the structure. You can see this is almost the same structure as of silica or diamond. This normally comes in the paper. So practice it. Properties of the silicon oxide are also similar to those of the diamond. Silicon oxide is a hard solid. Silicon oxide has very high melting and boiling points. Silicon oxide does not conduct electricity. Next topic in giant molecular structures is polythene. Polythene is a large molecule. It is polymer. A polymer is a long chain molecule made by joining thousands of the repeating units together. The repeating unit in polythene is the ethene molecule. Formula is C2H4. Figure shows the structure of the polythene molecule. Here is the structure. Practice it on the paper because this structure normally comes in the paper to draw. Black dot is carbon atoms. Here are carbon atoms and cross is hydrogen atoms. Properties of the polythene are intermediate between giant molecules and simple molecules. Polythene has a high melting point. Polythene does not conduct electricity. Now here comes a question. Carbon, proton number 6 and silicon, proton number 14 belong to the same group, that is group 4 of the periodic table. Carbon and silicon can combine together to form a compound called silicon carbide. A part's requirement is write the electron configuration for carbon and silicon. So in carbon there are 6 electrons, so configuration is 2,4. Whereas in silicon there are 14 electrons, so electron configuration is 2,8,4. B part. In the compound silicon carbide, first requirement is how many atoms of the carbon are bonded to one atom of the silicon? The answer is 4 because all 4 electrons will be bonded together. Second requirement is how many atoms of the silicon are bonded to one atom of the carbon? Again, answer is 4. Third requirement is what type of the bond is formed between silicon and carbon? Answer is covalent bond. Next requirement is draw the structure of the silicon carbide. So this is the structure of the silicon carbide. The silicon carbide has a giant molecular structure similar to that of the diamond. So this is the structure which is very important. So practice it on the paper again and again. This frequently come in the paper to draw. Last requirement is give 2 physical properties of the silicon carbide. So properties are similar to those of the diamond. Number 1, very hard solid. Number 2, has very high melting point. Next question is, which substance does not have a macromolecular structure? The answer is sodium chloride. Sodium chloride has a giant ionic structure, not macromolecular structure, that is made up of the lattice of the positive and negative ions held tightly together by strong electrostatic forces of the attraction, that is ionic bonds. Rest of all three, that is A, B and C, having macromolecular structure. Exam tip for you people is all macromolecules have atoms that are covalently bonded. Hence, ionic compounds do not exist as molecules. Another question is, which of the following describes the structure of the diamond? The answer is A part, a giant structure of the atoms bonded covalently. Diamond is a macromolecule made up of billions of the carbon atoms covalently bonded together. Exam tip for you people is, diamond is an allotrope of the carbon. That is, it is made up of the carbon atoms only. Just like graphite and other carbon allotrope, they have different physical properties. Another question is here, which substance has the highest melting point? So this is very important question. Remember, diamond is the element that is having the highest melting point. Diamond is a macromolecule. To melt it, a lot of the energy is needed to break the extremely strong carbon-carbon covalent bonds. Among all the four substances, it has the strongest bonds to break. Although the ionic bonds in the lead bromide are also strong. The exam tip is, methane and water also have strong covalent bonds between atoms. However, each molecule is attracted to other molecules by weak intermolecular forces of attraction. Hence, it has a low melting point with little energy required to break apart the weak forces of the attraction between the molecules. So this was the topic. Read it again very carefully and make your notes. Thank you so much.